Hello, ladies and gentlemen. I'm going to go over a few more trig proofs today. Some of the more crazy ones where you might have gotten stuck or think about, man, I don't know what I'm supposed to do to this to try to get that identity proven. We need to take a look at how to deal with some of those and how to write some proofs when they're a little bit more complicated, okay? So remember our general strategies. Begin with one side. Proof ends when you reach the expression on the other side. Show all your steps in between so one can easily see what you did. That's probably the hardest part. That's the preparation for an AP test, okay? So one can see what you easily did. You don't have to show every single step, but one needs to be able to follow your logic, okay? Begin with a more complicated expression, work towards the left. If you aren't sure, um, convert the entire expression to sines and cosines. Be careful about making common denominators, factoring, and always be mindful of what it is you're trying to accomplish in this proof. I'm trying to turn this into that, so think about steps that get you there, okay? And that's really the focus of our video today, is what do I do when I'm not sure what to do, okay? So, oops, I'm going to skip past number one here because we actually already did this one in our last video or in our last notes. So let's take a look at this guy right here. I'm going to relabel him number one. We are proving that sine t over 1 plus cosine of t is the same thing as 1 minus the cosine of t over the sine of t. Whew, well, looking through there, it doesn't look like one side's any more complicated, less complicated than the other. So in that case, I'm just going to pick a side. I'm going to work this left side again, you know, creature of habit, and I'm going to try to make him look like the other side. Now notice I don't have a cosine squared here. So I can't just turn it into things that are squared and use those trig identities involving that stuff. So I need to be a little bit more mindful of my end goal. In order to accomplish my end goal, I need to somehow take this expression, sine t 1 plus cosine t, and try to start thinking about how I could turn it into this side. Well, notice I have a sine t on the top of the fraction. My goal is to have 1 minus the cosine of t on the top. Well, I don't have anything close to that. So sometimes when you're working towards your goals, people, you just got to do it. You just got to put it up there, okay? So I am just going to multiply the fraction times 1 minus the cosine of t because you know what? I want that up on the top of the fraction. That's my goal. But what I do on the top of the fraction, I must also do to the bottom in order to maintain equivalency. So I'm going to take this fraction and multiply it by essentially what is a fancy form of 1, right? 1 minus cosine t over 1 minus cosine t. It's just 1. But by doing so, I'm going to get what I want on the top at least, and we'll see what happens with the rest. So when I multiply across, I'm just going to leave this as the sine of t times 1 minus the cosine of t, that looks like cost, right? Over, now the bottom, I might decide to FOIL this out. I'm just feeling like that might be a good call because I'm noticing I want to involve signs on the bottom, so I want to see what this is to make it better, worse, we'll see. So I'm going to FOIL this out. 1 minus the cosine of t plus the cosine of t minus cosine t squared. Well, this is looking useful because these guys would cancel out, right? And I'd be left with 1 minus the cosine of t. So if I have that, I might be able to just substitute in sine squared right there, right? So I'm going to go sine of t, 1 minus the cosine of t, all over sine squared of t. See where I got that? Oh, this is not in the right spot. There you go. 1 minus the cosine squared is a sine squared. Now what's helpful is I now at least have signs on the bottom, right? That's getting me closer to my goal. But sine t over sine t is, sine squared t is 1 sine left on the bottom. So I end up with 1 minus the cosine of t over the sine of t. And that's what I was trying to prove. I've accomplished my goal of getting it to look like the right side of that equation, okay? So let's take a look at the second one here. Same idea. I'm going to label that number 2. Same idea here. I want to try to think about, neither fraction looks really that more complicated than the other, I guess. So I'm just going to start on the left side. Work my way to the right. Well, what do I have on the bottom? 1 minus the sine of t, and I don't want that. I'm going to want to turn it into cosine squareds. The top I have just a 1, and I want 1 plus the sine of t. So again, if I'm thinking about my long-term goal, and I have nothing in this left side that's squared, so I don't really have any other moves, I might just take this entire fraction and multiply it by what I want on the top. So 1 plus the sine of t, then I'm going to multiply the bottom by that same thing, in order to keep my fraction equivalent, right? What you do to the bottom, you must do to the top, and vice versa, to keep equivalent fractions. So when I do that, I have 1 plus the sine of t over the top of, now again, I might FOIL these two things out here, giving me 1 minus the sine of t plus sine of t minus sine squared of t. So the sine of t's would cancel out. I'd have 1 plus the sine of t over 1 minus the sine squared of t. Now this whole bottom can turn into cosine squared. And that is exactly what we wanted. Oops, I changed my t to an x. There we go. That's exactly what we wanted, right? I wanted a cosine squared on the bottom. That is what I wanted the top to look like. So I have finished my proof. I have proven that the left side is in fact equivalent to the right side by working one side of the equal sign. Okay? Maybe we'll do one more. This one looks pretty yucky, right? Yeesh, this looks a little bit scary. Well, again, thinking about my long-term goal, working my left side, I want this to turn into this. Looking at the top, I have a cosine t minus a sine t. This top of the goal here says that I want cosine t minus sine t squared. In essence, that's two of them being multiplied by each other. So I'm feeling like my plan is to once again make my goals happen. That's a good life skill, right? So cosine t plus sine t is what I currently have on the bottom and the top, but I'm going to multiply the top by another one of those in order to get my goal of two of them being multiplied on the top, but then I must also do that to the bottom of my fraction. So times that fraction, and then if I don't really have to multiply across the top, right? How do I know that I don't? Because it looks just like my goal. Sine t. Two of them. The bottom, however, ooh, I don't really want that thing times that thing. I'm working to get it to look like this. So I'm feeling like foiling it out might be a good plan. So cosine t times cosine t gives me cosine squared of t. Cosine times a negative sine gives me a negative cosine t sine t. Underneath, positive plus cosine t sine t. And then minus sine squared of t. So again, cosine t, sine t's, these terms in the middle here, because one's opposite of the other, cancel out. And we have cosine squared minus sine squared. Well, that's closer to what I want, but not exactly. What am I going to do with that? How am I going to make that happen? Well, let's think about what we can do. Let's take this cosine squared and turn it into 1 minus sine t squared. That's equivalent to that, right? And then if I subtract that other sine squared t, I'm working my way towards my goal. How did I know to get rid of the cosine squared and turn it into a sine squared? Because I looked at my goal, right? I looked at the goal. The goal is to only have sine squareds. No cosine squareds down there. So I knew I needed to remove those and replace it with something about sine. So now that I look at what I have, I'm going to continue over here a little bit. I have cosine t minus sine t being squared all over, this is 1 minus or subtract 2 sine squared t's. And that is exactly what I was trying to prove. Okay, So trig proofs take a little bit of getting used to, but they're a little different than geometry proofs where we don't have to write out all the words like segment addition property and things like that, but we're still following a logical sequence to accomplish our end goal, keeping the goal of what we're trying to prove in mind, okay? So I want to thank you again for taking good notes. Kincaid out.